All right, this is chapter 5B bonus assignment video number 2, and I have my periodic table problem figured out. So I asked you to do these problems, number 9, to figure out the difference in electronegativity and to then figure out whether the bond is polar, nonpolar, or ionic. So I will do this for you. I'm hoping that you have already done it because I want you to learn the material and do better on your test. Okay, so C bonded to F. I need to get my face out of the way. All right, C has a value, an electronegativity value. It's in the bottom right-hand corner of 2.5. So C is 2.5. H is 2.1. That minus that equals 0.4. So 0.4 difference is a non-polar covalent bond. All right, N triple bonded to N. Doesn't really matter what it is, but N is 3.0 minus 3.0 equals 0. So that difference falls in the 0 to 0.4 range. So that's another nonpolar bond. All right, S bonded to O. S has a value of 2.5 right there. O has a value of 3.5. So you take the big number minus the little number. S is 2.5. O is 3.5. 3.5 minus 2.5 equals 1. Okay, that is greater than 0.4. So that bond is, in fact, polar. All right, and then NaCl, that's actually a metal. Sodium is a metal. Chlorine is a nonmetal, so that is an ionic bond. So I'm going to say not relevant. We don't use electronegativities if the bond is ionic. So this is an ionic bond because we have a metal plus a nonmetal. Okay, and then on question 8, I want to go back to this one. As the difference in electronegativity becomes greater, does the bond get more or less polar? So if you look here, the CH bond is 0.4. That's nonpolar. N bonded to N is nonpolar. S bonded to O is polar. I guess I don't have a good example, so never mind that. Okay, so moving on. Let us turn the page, okay? This is the next section. This is about intermolecular forces, and I want you to read this right here, all right? Because I wanted to try to explain it. The part that you just did was about bonds. Bonds are forces within a molecule that hold the atoms together in the molecule. Sometimes they're called intramolecular forces because intra means within. You learned about ionic, polar covalent, and nonpolar covalent. Rank the 3 kinds of bonds from the strongest to the weakest. All right, I did this demo back in section 5.1 when I melted things on the hot plate in the front of the room. The strongest of these 3 bonds is ionic. Okay, that is when I tried to melt that salt, and it never was going to melt because they're held together so tightly. The weakest one that I melted was the wax because that melted very quickly. So that's non-polar covalent bond. All right, and then the middle one was polar covalent. That was the sugar, which melted after the wax, but sooner than the salt. So the quicker it melts, the weaker the bond. All right. So ionic's the strongest bond, polar covalent are the middle, nonpolar covalent are the weakest. All right, so let's talk about these intermolecular forces. They are forces between molecules that hold molecules together. Inter means between. We always abbreviate this as IMF. All right, so on this picture right here, it says label the intramolecular forces and the intermolecular forces. Well, the intramolecular forces are the bonds. So I'm going to try to highlight the bonds here with my yellow. That's a bond, 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 that's a bond. So I'll circle that with yellow. All right, and the intermolecular forces are between the molecules. I'll do that in blue. Okay, so those are the blue ones. So inter is between molecules. All right, and you learned about 3 different kinds. All righty, London dispersion, dipole-dipole, and hydrogen bonding. 3 kinds of intermolecular forces. Okay, these are different than bonds. They're between molecules. That's a molecule. That's a molecule. That's a molecule. The forces are between the molecules. All right, and these forces are based upon the structure of the molecule. All right, in every single case, they're attracted to each other. The negative side of one thing, I'll just do some generic molecules here, is attracted to the positive side of the other thing. Okay, every single time, no matter what, the force is opposites attract. The positive end of one molecule is attracted to the negative end of the other molecule every single time. Okay, sometimes it's stronger and weaker, but that's always the case. It's always between the negative of one and the positive of the other one. Okay, and the structure determines if the molecule is nonpolar or polar. So this was one of the hard things. You had to be able to draw the Lewis dot structure and figure out if the molecules were polar or nonpolar. So I'm going to write a little note right here. Draw Lewis dot structures to figure this out. All right, and remember your VSEPR, your shapes. I'll just write shapes here, okay? All right, so let's fill in this column, okay? Molecules that have only positive and negative parts temporarily, they don't last. Those are your nonpolar molecules.